100 kilometers from Moscow, near the science town of Protvino, a treasure trove of tens of billions of rubles is buried in the forests of the Moscow region. It cannot be dug up and stolen, forever buried in the ground. It is of value only for the history of science. We are talking about the Accelerator and Accumulation Complex (AAC) of the Institute of High Energy Physics Protvino, a mothballed underground facility almost the size of the Large Hadron Collider. The length of the gas pedal's underground ring is 21 kilometers. The main tunnel, with a diameter of 5 meters, is laid at a depth of 20 to 60 meters, depending on the terrain. In addition, many auxiliary rooms connected to the surface by vertical shafts have been built. If the Proton Collider in Protvino had been delivered on time before the LHC, a new point of attraction would have appeared in the world of fundamental physics. Further, about the history of the main Soviet collider, which could forge the physics of the future. The biggest project. Many years before the strategic decision to build the largest scientific facility in the USSR, in 1960, a secret settlement Serpukhov 7 was founded as a base for the Institute of High Energy Physics, IFHE. The site was chosen for geological reasons. In this part of the Moscow region, the soil, which is the bottom of an ancient sea, allows the location of large underground facilities protected from seismic activity. In 1965, the city received the status of an urban-type settlement and a new name, Protvino, derived from the name of the local rivulet Protva. In 1967, Protvino launched the largest gas pedal of its time, the proton synchrotron, at an energy of 70 GeV, 109 electron volts, U70. It is still in operation and remains the most high-energy gas pedal in Russia. Soon they began to develop a project of a new gas pedal, a proton-proton collider at an energy of 3 TeV, 1012 eV, which would become the most powerful in the world. The work on the theoretical justification of the UNK was headed by academician Anatoly Logianov, a theoretical physicist and scientific director of the Institute of High Energy Physics. The synchrotron U70 was planned to be used as the first booster stage for the UNK gas pedal. Two stages were envisioned in the UNK project. One was to receive from the U70 a proton beam with an energy of 70 GeV and raise it to an intermediate value of 400 to 600 GeV. In the second ring, the second stage, the proton energy would be raised to its maximum value. Both stages of the CNA were to be placed in one circular tunnel with dimensions exceeding the circular line of the Moscow subway. The fact that the construction was carried out by Moscow and Alma-Ata metro engineers adds to the similarity with the subway. Experiment plan. At the beginning of the 80s, there were no gas pedals of comparable size and energy in the world. Neither the Tevatron in the USA, ring length 6.4 kilometers, energy in the early 1980s, 500 GeV, nor the Super Collider of the CERN laboratory, ring length 6.9 kilometers, collision energy 400 GeV, could give physics the necessary tool for new experiments. Country had great experience in the development and construction of gas pedals. The synchrophasotron built in Dubna in 1956 became the most powerful in the world at that time, energy 10 GeV, length about 200 meters. At the synchrotron U70 built in Protvino, physicists made several discoveries. They registered antimatter nuclei for the first time, discovered the so-called Serpukhov effect, an increase in the full cross-sections of hadronic interactions, values that determine the course of the reaction of two colliding particles, and much more. Decade-long work. In 1983, construction work at the facility began by mining method, using 26 vertical shafts. For several years construction work was carried out in a sluggish mode. Only 1.5 kilometers were covered. In 1987, the government issued a decree to intensify the work, and in 1988, for the first time since 1935, the Soviet Union purchased abroad two modern tunnel boring complexes of Lovat Company, with the help of which Proton and Elstroy began to lay tunnels. Why was it necessary to buy a tunnel boring machine if the country had been successfully building subways for 50 years before that? The fact is that the 150-ton Lovat machines not only drilled with a very high accuracy of penetration to 2.5 centimeters, but also lined the tunnel vault with a 30-centimeter layer of concrete with metal insulation, ordinary concrete blocks with a sheet of metal insulation welded on the inside. Much later in the Moscow metro, a small section of the Trubnaya-Sretensky Boulevard line will be made of metal insulated blocks. At the end of 1989, about 70% of the main ring tunnel and 95% of the injection channel, a tunnel more than 2.5 kilometers long, designed to transfer the beam from U70 to UNK, were completed. 3 buildings, out of the planned 12, of engineering support were constructed. Construction of ground facilities was started along the entire perimeter, more than 20 industrial sites with multi-story production buildings, to which water supply, heating, compressed air, high-voltage power lines were laid. During the same period, the project started to have problems with financing. In 1991, with the collapse of the USSR, the UNK could have been abandoned immediately, but the cost of preserving the unfinished tunnel would have been too high. Destroyed, flooded by groundwater, it could have posed a threat to the ecology of the entire region. It took another 4 years to close the underground tunnel ring, but the gas pedal part was hopelessly behind. Only about 3/4 of the accelerating structure for the first stage of the UNK, and only a few dozen magnets of superconducting structure, and 2,500 were required, each weighing about 10 tons. The magnet system is one of the most important in the gas pedal. The higher the energy of the particles, the harder it is to get them on a circular trajectory, and, accordingly, the stronger the magnetic fields must be. In addition, the particles need to be focused so that they do not repel each other as they fly. Therefore, along with magnets that rotate the particles in a circle, focusing magnets are needed. The maximum energy of gas pedals is basically limited by the size and cost of the magnet system. The injector tunnel turned out to be the only part of the complex that was 100% ready. Since the orbital plane of the UNK is 6 m lower than in the U70, the channel was equipped with an extended section of magnets, providing a 64 degrees beam rotation. The ion optical system ensured that the phase volume of the beam taken out of the U70 was matched to the rotation structure of the tunnel. At the moment when it became clear that there was no money and we should hold on, all vacuum equipment of the injection channel, pumping systems, power supply devices, control and monitoring systems were designed and obtained. A stainless steel vacuum tube with a pressure of less than 10 to 7 millimeters of mercury column is the basis of the gas pedal, and particles move through it. The total length of the vacuum chambers of the injection channel and 2 stages of the gas pedal, the output and discharge channels of the accelerated proton beam, was to be about 70 kilometers. In 1994, the builders completed the last and most difficult in hydrogeological conditions, due to groundwater, section of the 21-kilometer tunnel. During the same period, the money practically dried up, because the project costs were commensurate with the construction of a nuclear power plant. It became impossible to order equipment or pay salaries to workers. The situation was aggravated by the 1998 crisis. After it was decided to participate in the launch of the Large Hadron Collider, the completion of the UNK was finally abandoned. The LHC commissioned in 2008 turned out to be more modern and powerful, finally killing the idea of resuscitating the Russian collider. However, the giant complex cannot be simply abandoned, and now it is a suitcase without a handle. Every year, money is spent from the federal budget to maintain security guards and pump water out of the tunnels. The money is also spent on concreting numerous climbing tunnels that attract fans of industrial exotics from all over Russia. Over the last 10 years, various ideas for renovating the complex have been proposed. The tunnel could house a superconducting induction storage device that would help maintain the stability of the power grid of the entire Moscow region. Or a mushroom farm could be built there. There are many ideas, but all of them are hampered by lack of money. Even to bury the complex and fill it completely with concrete is too expensive. For now, the unclaimed science caves remain a monument to the unfulfilled dream of Soviet physicists. The presence of the LHC does not mean the elimination of all other colliders. The U70 gas pedal of the Institute of High Energy Physics is still the largest operating one in Russia. The Nika heavy ion gas pedal is under construction in Dubna near Moscow. Its length is relatively short. Nika will include 4 200-meter rings, but the area in which the collider will operate should provide scientists with observation of the boundary state, when nuclei and particles released from atomic nuclei exist simultaneously. For physics, this area is considered one of the most promising. Among the fundamental research to be carried out using the Nika collider is the modeling of the microscopic model of the early universe. Scientists intend to use the collider to search for new methods of cancer treatment, irradiation of tumors with a particle beam. In addition, the facility is used to study the effect of radiation on the operation of electronics.